Hi, Grace. Sorry for the delay in the video. My screen record software was not working today when I tried to make your video earlier, and the tech department had to get a hold of my machine and try to get it repaired. And so I think we're good now. I've got your unit review here pulled up. I'm going to go over the 5 questions that you missed, and then I will add or I'll reset the activity so that you can work on it again. So question 1 asks, which of the compound inequalities has no solution? So a compound inequality works with the word and or, and we want to make sure that there are numbers that fit that situation. So the correct answer is the first one. So I'm just going to kind of walk through that, how to solve it, and why this one has no solution. So I'm going to rewrite the problem over here. We've got 1/3 x plus 5 is less than 5, and 2x plus 1 over 3 is greater than 1. So we need to solve both of these inequalities and then see what the solution sets tell us and why this one has no solution. So on the left-hand side, I'm going to subtract 5 from both sides of the inequality. That leaves me with 1/3 x is less than 0. I'm going to multiply both sides by 3 to get rid of that 1/3 that's in front of the x. So I have x is less than 0. On the right-hand side, I'm going to multiply both sides by 3, again, to get rid of that fraction. 2x plus 1 is greater than 3. Now we're going to subtract 1 from both sides. 2x is greater than 2, and then we're going to divide both sides by 2. X is greater than 1. Now this is an and inequality, so I'm going to bring down that word and. I'm going to rewrite both of these solutions to the inequalities. So x is less than 0 and x is greater than 1. That means we are looking for a number that fits both of these statements. If I draw a number line, we're going to plot 0 and 1 on the number line. They both would be open circles because we're just less than or greater than. We're not actually including 0 or 1. But x is less than 1. We would be talking about numbers shaded to the left here, all the negatives. And x is greater than 1. We'd be shading towards the right here, all the numbers that are positive, or excuse me, all the numbers that are greater than 1, but they are positive. So what we're trying to do is find a number that fits in both of these parts, and it turns out there is not a number that is both less than 0 and greater than 1. That just can't happen. So if the number is less than 0, it's negative. If it's negative, it's not greater than 1. So that's why this inequality has no solution. Typically with the or inequalities, those aren't going to have no solution because it can do this or it can do that. It doesn't have to do both. So my guess would be that both of those ors have solutions. Obviously, I'm not going to solve them both, and the same thing with that and solution at the bottom. It must be something that we've got some overlap somewhere where there are numbers that will work. So that first one is the one that is no solution. Question 2 says we have a pumpkin patch. It's asking Armando guesses the weight of his pumpkin. Within 0.3 pounds, he gets to take the pumpkin home for free. If his pumpkin weighs 4.9 pounds, which equations can be used to find the minimum and the maximum weights he can guess in order to get his pumpkin for free? So as we look through these solution options here, we see some similarities, right? We're either adding or subtracting 0.3 from x, and then we're setting it equal to 4.9 and negative 4.9, or we're adding or subtracting 4.9 from x and setting it equal to 0.3 and negative 0.3. So we can start a couple of different places. One thing I'm thinking is that if we're 4.9 pounds, if that's what it weighs, and we have to be within 0.3 pounds, that means we can add or subtract 0.3 from 4.9. If we add 0.3, we're going to get 5.2. If we subtract 0.3 from 4.9, we get 4.6. So his guess can be anywhere from 4.6 to 5.2. The question is, which of those equations there, the setup, is going to tell us all the possibilities for maximum and minimum weights that he can guess. We know it's 5.2 and 4.6. So we look at that correct answer down there. We know that if we add 4.9 to both sides on the left equation, and we add 4.9 to the left and the right of both sides of that equation, we end up with x is equal to 5.2, and we also get that x is equal to 4.6. So there are the two numbers that our guess can fall between, or his guess can fall between. So what they're doing is they're taking his guess, which is x, right? We don't know what he guessed, but if his guess is x and we take away the weight of the actual pumpkin from the guess, we either have to be 0.3 over or 0.3 under, which is where that 0.3 and negative 0.3 come into play. If you check out the solution that you picked, the first one, we do solve this, we do get 5.2, but when we solve this second one, if we try to add 0.3 to both sides, we get that x equals negative 4.6, and we can't have a negative weight. So that first one that you selected does not work. Question 8 asks for you to use properties to rewrite the given equation, which equations have the same solution. So as I look through the option choices, they haven't done a ton in terms of the solving. It looks like the left-hand side stays pretty much the same throughout. They do a couple things in these third and fourth options that we'll talk about. But on the right-hand side, it does look like they've combined these two pieces. Those are like terms. So if I don't mess with the left-hand side, but I combine like terms on the right-hand side, I'm subtracting 0.01p from 6.5p. I get 6.49p, and then I bring down the minus 4. So you can see that's that answer choice that you did select there. The next one that's correct, which is the third option, and we look at numbers that don't have decimals anymore. Oftentimes, we can teach students, multiply everything by 10 or multiply everything by 100. We can get rid of the decimals. Some students find that easier to work with. I don't typically do that with decimals. Students have access to calculators, so things aren't terribly difficult to solve. I will teach students how to get rid of fractions because they hate fractions. But it looks like in this next option, they've taken 2.3, the decimal was here, and now they've moved it 2 times to the right. So it's like multiplying everything by 100. They've multiplied the entire equation, which is every single term, by 100. And if you do that, you do get this third option here, this 230, that's 2.3 times 100. 1010 is 10.1 times 100. 650 is 6.5 times 100. 400 is 4 times 100. And then that 0.01 times 100 does give you 1. Remember that multiplying by 100 is the same as moving the decimal 2 times. So if I go back over here on the right to this equation, I move my decimal twice, I move my decimal twice, move it twice. You can see how we're getting these numbers. Move this one twice, and it puts the decimal right behind the 1. So you just get basically like 1p, 1.0p, or just p. So that third option is also correct. We're close here on this one. They multiplied everything by 10 until they got to this piece. That piece has been multiplied by 100. If I multiply 0.01 by 10, I'm going to move the decimal 1 time to the right, and I'm going to get 0.1p, and that's not what they have here. So you can't multiply every term by 10 and then multiply the last one by 100. We don't have the same equation anymore. They're not going to give me the same solution because it's not the same equation anymore. This last one, they've incorrectly combined like terms. It looks like they only took 1/10 away instead of 100 from 6.5. So that doesn't work there. And I'm not really sure what's going on with the 14.1. It's 10.1. I think maybe are they adding 4? I'm not sure, but that last one's definitely incorrect. But that's why the 2 correct answer choices are correct. Question 9, we've got an axis of symmetry equation. We have a formula here that says x equals negative b over 2a. We don't really need to know that it's an equation to find the axis of symmetry. A and B are coefficients in the quadratic equation. We haven't worked with quadratics yet, but the whole purpose of this problem is because this is a literal equation where we are asked to solve for a different variable, right? So we've got this equation with multiple variables in it, and we are asked to solve it for A. Literal equations are one of my algebra students' least favorite things to do. It's just a little confusing. I got all these letters. And really, you're just kind of treating things like numbers. You know, how would you solve that for A if X and B were numbers instead? I have some students who will actually plug numbers in, and then things start to make a little more sense to them. You know, and that's an okay tactic, but this is how we would solve this equation. First, whenever you're trying to solve for a variable that's in the denominator, you have to get it out of the denominator first, and we do that by multiplying both sides by A. When I multiply it by A on the right, those A's are going to cancel each other out. On the left, A times X is just AX, and then I'm left with negative B over 2. Now I can pretty easily get rid of that X because I'm solving for A. I want to get A alone. I'm going to divide both sides by X, right? This is multiplication. I undo that through division. So those X's are going to cancel. I do now have A on the left-hand side by itself, but I need to clean up what's going on the right-hand side. Basically, this is what we call a complex fraction, right? I'm going to kind of darken this fraction bar here. I have a fraction that has a fraction as a numerator, and that's not simplified. It's not considered simplified. We got to clean it up. So when we divide fractions, we're taking negative b over 2 and we're dividing it by x. We are going to multiply by the reciprocal. The reciprocal of x, if I were to place that over 1, is 1 over x. Oops. And now I just multiply across the top and multiply across the bottom. And you see how we get negative b times 1 is negative b. And on the bottom, 2 times x is 2x. If you go back to the original, it looks like a and x just kind of switched places. I talk about that with my students, but I certainly make sure that they understand the algebra of solving the equation to get the correct answer. The last one asks for the solution to the absolute value equation. So when we have absolute value equations, the first thing that we have to do is get the absolute value bars all by themselves. Okay, I don't care what's inside, but I've got to get rid of anything on the outside. And here we have a 3 that's being multiplied by that absolute value part of this equation. So I am going to divide both sides by 3. That's the opposite of multiplying, so we're going to get rid of that. I'm going to bring down those absolute value bars, and I'm going to bring down all that mess that's inside. And on the right-hand side, negative 18 divided by 3 is negative 6. So now we have the absolute value of something needs to be equal to negative 6. And what we know about absolute value is how far away something is from 0. It's really considered like a distance. How far are we from 0? And distance can't be negative. So whenever you have the absolute value set equal to a negative number, you're going to get no solution. I'm going to guess that you went ahead and solved you set up the two equations and solved them both. And you probably do get negative 5 and 1 when you set the absolute value equal to positive and negative 6. But we got to go back to what this says right here. This says, and what you're trying to figure out is what can I make x be so that when I take the absolute value of all of this inside, I get negative 6, and you're never going to get negative 6, right? If the inside is negative 6, I get 6. The absolute value of negative 6 is 6. And if I somehow get 6 on the inside, the absolute value of 6 is also 6. You're never going to get negative 6 when you take an absolute value. So this one has no solution. I hope this helps clear a few things up. I am going to add a retake on that. Let me know if you have any other questions. Have a good night.